right, so we're going to do part 2 of our introduction and examples to functions and function notation. And we'll start with an example around what's called mapping diagrams. Okay, so if we have, let's see, if we have this particular relation right here, it's just, remember, relation is just a set of points. Then we can kind of visually write those points in this way using a mapping diagram. So that means 2 gets mapped to 1, 3 gets converted to a 6, 5 turns into a -2. By some mysterious function rule or function machine, it's taking those input numbers and turning them into the outputs. Again, we don't really care what the rule is. We don't care what the equation is at this point. We're just seeing a 2 get fed into a function machine or a number machine, and it gets spit out as a 1, etc. Okay? This first example of a mapping diagram is an example of a function because for every particular member of the domain, we only get output one member of the range. And I want to contrast that with this next one down here, okay? And maybe take a look at it, see if you can notice what's different about it. Some of the numbers are different, that doesn't really matter too much, but there's a more fundamental difference. When we feed our function a 2, it spits out a 1, but sometimes it spits out a -3. So that's something to really notice, and that's what makes it not a function. What I often say in my classes is this makes this not predictable. We don't know what the 2 is going to turn into. We don't know if it's going to turn into a 1 or if it's going to turn into a -3. We want at least a little predictability in our lives, right? Let's contrast though up here, and I'll use a different color to highlight. Look at this guy. The 3 turned into a 6 and a 0 also turned into a 6. That's allowed, okay? It's okay to reach the same number of the range from 2 different starting points. That's completely allowed. It's predictable. We know the 3 is always going to end up at a 6. We know the 0 is always going to end up at a 6. That's allowed. But what's not allowed is this one down here where the 2 sometimes turns into a 1 and the 2 sometimes turns into a -3. So that's what makes that second relation not a function. Let's look at the vertical line test right here, and these are the same points from our non-function from above. And I just want to reinforce how we can use the vertical line. Even if we only have discrete points, it only looks like we have 4 points. But if we can ever draw a vertical line that hits 2 points, and we're hitting those 2 points right there, that's what makes this a non-function. Of course, it's still a relation. It's still a set of ordered pairs, totally valid to graph. It's just not something special called a function. Another example of a vertical line test using absolute value over here, an absolute value function, and we can draw as many vertical lines as we want, and we would never cross the graph twice. Okay, so this is an example of a function. The fact that a horizontal line hits the graph twice doesn't matter. Okay, it'll matter later. Maybe in Algebra 2 it'll matter, but for now, horizontal line double hitting doesn't matter. We just really want to make sure the vertical line doesn't cross the relation twice. That would void it from being a function. Last one, or almost the last one for this guy, I want to talk about evaluating a function. Remember, evaluating just means plugging in. Okay, that just means plug in. Okay, so here we have our particular function f of x equals 3x minus 5. And that just means that this function has its singular job in life is to take whatever it's given, triple it, and then subtract 5. So whatever number we feed it, it will triple it, multiply by 3, and then subtract 5. So for this first one, we're going to do 3 times 0 minus 5 and get -5. So f of 0 is -5. F of 1 is -2 because 3 times 1, take away 5 is -2. And f of 2, 3 times 2 minus 5 is a +1. Okay, so evaluate just means plug in. And really what's also particularly important here is just remember we're not doing f times 0. This is just different notation, different way of representing y, f of 0, f of 1, f of x, etc. And then finding the range for our last example here, we have this particular equation y equals x squared minus 2. We should probably graph it up first. I've done it for you already. And we should probably next think about, is this a function? Okay, does it pass the vertical line test? It looks like it does. It's a parabola, a vertical parabola, which will be a function. It's predictable. Every x value leads to its own y value. But let's think about what the range would be here. Okay, so the range, it looks like, is everything at -2 and above. It looks like this parabola will never have any points below -2. So the range of this guy is y is greater than or equal to -2. The domain is x is all real numbers. Okay, x can be anything. We're allowed to plug any numbers in for x into this equation, and we will get out a y. But there are many possible y's that we will never get out, right? It's impossible to plug a number in for x into this equation and get a -3 out for y. Okay, so the range is y is greater than or equal to -2. It's a good place to stop right there.